Hello everyone, my name is Manish Teja Ganta and this presentation is a brief overview of my research paper for MISI 742, which is Use of GIS in Forensics. In this presentation, I would like to speak a few words about what is GIS and its uses, geospatial information technologies in forensics, uniqueness of geospatial information technology, spatial analysis using GIT, technologies in forensics, crime scene investigations and spatial technology, challenges, and a conclusion on the topic. So, what is GIS? GIS, or a Geographic Information System, is a computer system for capturing, storing, checking, and displaying data related to positions on Earth's surface, which is also known as spatial data. The first known use of the term geographic information systems was by Roger Tomlinson in the year 1968. So there is no exaggeration in acknowledging him as the father of GIS. Previously, there were a few incidents in history where spatial data was used to analyze in Paris and in London, but Tomlinson was the first ever to use computer and spatial data to locate a perfect location for the project given to him. The other uses of GIS nowadays are mapping data, which is representing data in the form of map. Proximity analysis, like distance between a point A and B, and also buffering to find clusters and location analysis. Geospatial information technology, which in other words can also be called as geographic information systems, has been used for many years in crime mapping around the world. Its purpose is to provide technical skills to use georeference data. Companies such as CSIR in New Zealand use GIS to provide forensic evidence for criminal cases. Not only in criminal cases, but GIS is used in every part of the investigation process, creating jobs in the public, private, and university sectors. Jobs are being created like GIS analysis expert witness support for litigations in companies like Digital Data Services or Geographic Resource Solutions. And according to the American Centennial University, GIS and geospatial skills are a critical part of forensic science education today. From these facts, we can say GIS is the future of forensics. Coming to the uniqueness of GIT, geospatial information technology has a few features up its sleeve which make it so unique that it can be integrated into any field. Some of these features are geovisualization, geodatabase, 3D visualization and analysis, and similarly dynamic and static analysis. Coming to geovisualization, it is the technique used in reduction of complex datasets to informative maps. It provides coherent visualization of large volumes of data from diverse sources. Geovisualization offers an innovative approach to present and discuss results of data collection, data analysis, and data simulation visible to layman. After all, the main purpose of doing this is to make a normal person understand complex data so that a decision can be made about the crime. Here are a few pictures representing a geovisualization of a crime, which is human trafficking. And on the right, we can see a statistical map representing the statistics about about burglaries, the rate of burglaries in USA. So coming to GeoDatabase. The GeoDatabase is the common data storage and management framework for GIS. Simply put, it is a container for spatial and attribute data. The name itself explains everything. Geo refers to the spatial data combined with database. It is like having all GIS data stored uniformly in a central location for easy access and management. We, we can see from this picture that it provides single user and multiple user access with relational data management systems. So, by storing GIS within a geodatabase, users can take advantage of its superior data management capabilities to leverage spatial information. This will in turn enhance the chance of solving crimes. Here we can see a picture representing a geodatabase. From it we can see it supports both single user and multiple user with relational database management. All the GIS data is at one place for easy access. So coming to the 3D visualization, generally, as we know, maps are in two-dimensional data. So there is always some or the other aspect that we miss to grasp while using them, and this is a major disadvantage. But by converting them into 3D maps, better visualization can be obtained. To do this, first, the geocode crime scene data must be processed and analyzed with GIS methods. For example, a GIS method like kernel density estimation can be considered, and by applying this method to a robbery hotspot to the scene, a robbery hotspots can be identified. So these hotspots are combined with a 3D city model for this minimum distance of each building to the closest crime scene can be determined. This spatial data is combined into the three-dimensional geo-virtual environment which is modeled outside the GIS. From this 3D model and the hotspots, crime-affected areas can be identified easily. From the 3D picture, we can see the three-dimensional layout of a city block and the places where robberies took place. The red spots are the places where some of the robberies took place. So this is a better visualized data than a 2D map. This might help the police while investigating some cases to find out certain patterns in the robberies or any other kind of evidences. So coming to spatial analysis using GIT, spatial analysis includes any of the formal techniques which study entities using the topographical, geometric, or geographical properties. Some of these techniques are map algebra. Map algebra is a cell-by-cell combination of raster data layers stacked on top of each other. A simple operation like addition multiplication are applied to each raster cell location to get the required result. So, to be more clearer, all the data is divided into equal cells and all the cells are combinedly form a grid. Each cell is assigned a value based on the quantity of variable being measured. One advantage of raster GIS is that it is easy to represent continuous data such as distance from another cell like distance from a major road or degree of concentration like density of the crime. Once the individual layers are calculated, then they can be used as parameters in mathematical equations. Similarly, spatial analysis also has some other techniques such as network analysis, 3D analysis, space and time, spatio-temporal analysis, and tracking analysis. So there are certain technologies related to forensics such as Global Positioning System, also known as GPS, Ground Penetrating Radar, also known as GPR, and remote sensing, thermal imagery, and radio frequency. Coming to GPS. GPS, as everyone knows, Global Positioning System, is used to identify locations. This data can serve as evidence in several high profile cases like terrorism to homicide to kidnapping. It can also play a significant role in many other types of investigations like accident reconstruction and search and rescue. Usually, there are two levels of data: system level and user data. System level has track points and track logs. Track point is like a record of when the GPS has where the GPS has been, where the GPS is turned when the GPS is turned on, it will begin to record all the locations that the GPS has been to, like an electronic breadcrumb trail. Track log is the complete list of the track points. Coming to user data has waypoints and routes, where waypoints is the location where the was physically present, and route is a series of waypoints in a specific order. Coming to ground penetration radar. Ground penetration radar is a geographical method that uses pulses to image the surface. Ground penetrating tool is a key tool used by law enforcement and crime scene investigators for locating clandestine burials and buried objects. GPR has been instrumental in locating victims' hidden caches of weapons or evidences and helping to locate the remains of soldiers and civilians killed in war zones. Here from the picture we can see this is a ground penetrating radiogram collected on a historic cemetery in Alabama, USA, where the hypergraphical arrows indicate the presence of a defacting buried beneath the surface, possible association with human burials. Reflections of soil layers are also present they are denoted by using dashed lines. Crime scene investigation and spatial technology. In this, all the above techniques and technologies explained so far has one purpose in common: preventing, preserving and making information understandable and presentable in court. For this to happen, the forensic team does things like crime scene accident representation, reconstruction, simulations. They also perform shoeprint and vehicle tire analysis to make the data and evidence presentable in court. For all of the GIS is for all of this, GIS is like the backbone. So, coming to the challenges, with all these unique qualities, GIS can be considered as a very useful development in the field of forensics. For the matter, for that matter, in any field, it can be considered as a very useful development. But though it is a very ad- advanced technology, it has its own weaknesses and challenges. One of it is accuracy and validation. Even though we have spatial data, no one can be 100% sure that it has no errors, and most of the results obtained from this data are through simulation, which are just artificially generated results. So validation is a factor. Geoprofiling weakness can also be a factor. Like many theories are used in geoprofiling, assuming that they are correct, but everyone does not believe in the same theories. So data obtained through these theories is not accepted by all. And coming to financial factor, like every other thing in financial consideration is also a factor because everything runs on money. So coming to the conclusion, though we have many Though we may face few challenges while integrating GIS into forensics and crime mapping, the results that we achieve from these are far more valuable. So no matter what it takes, all the challenges must be overcome and GIS must be put to use for the greater good. Thank you.